How to solve this complex radical problem? It's a little challenging and tricky. Here is square root of 2 plus square root of 3 minus the square root of 2 minus square root of 3. Before start the solving of this question, I want to explain a little about the compound root. What's compound root? If you have the root like a plus 2 square root of b, how you can solve this type? You can find two numbers to multiply, give b, and add give a. Actually, it's a perfect square. Then write the m and n, square root of m and square root of n. The sign between m and n take from 2 here. If it's positive, you can write here positive, and if negative, you can write here negative. It's actually a formula or rule you should keep in mind. But how we can solve this question? It's a little tricky. So here we can write square root of 2 plus square root of 3 minus the square root of 2 minus square root of 3. But you have to first prepare this expression to the form of compound root. Here a plus 2 multiplied by b, or multiplied by x square root of b. So how we can convert or change the form of this expression here? Pay attention. We can write 2 plus square root of 3 over 1. Also the same here, 2 minus the square root of 3 over 1. As you know, when any improper fraction doesn't have denominator, the denominator is 1 all the times. So here these two expression that doesn't have, or actually don't have a denominator, its denominator or their denominator source are 1. Then we can write here the same, 2 plus square root of 3 over 1. We multiply both numerator and denominator by 2. Here also write a 2, and here also write a 2, minus the square root of 2 minus square root of 3 here over 1. We multiply both denominator and numerator by 2. Then here the form change, and 2 multiplied by 2 gives us 4 plus 2 times square root of 3 over 2 multiplied by 1, 2, minus 2 multiplied by 2, 4, and 2 times of square root of 3 here over 2 multiplied by 1, 2. Then we can use from this trick here. We have 4 actually. Then here we have 4 minus or plus actually the first one, 2 square root of 3. I write this part to here. Here we can find two numbers to multiply give us 3 and add give us 4. So proper and perfect number is 1 and 3. 1 multiplied by 3 give us 3, and 1 plus 3 give us 4. So here we can write square root of 3 plus square root of 1. And also the second part here, we have 4 minus 2 times of square root of 3. The same, we find two number, gave us 1 multiplied by 3, and 1 plus 3 gave us 4. all the time you keep in mind that the big one or larger should write first. Here, square root of 3 minus square root of 1. So now we write, instead of, here we take the square root of denominator and numerator separately, and we can here write 4 plus 2 square root of 3 over square root of 2 minus, here the second part also we take the square root of separately numerator and denominator, 4 minus 2 square root 3 over square root of 2. Then we, instead of this one, we substitute, put this one, its value is square root of 3 plus square root of 1 over square root of 2 minus, here also instead of this part we substitute its value is square root of 3 minus square root of 1 over square root of 2. Then because the denominator are the same, equal, we take one of them square root of 2 and we subtract the numerator square root of 3 plus square root of 1, and we multiply the sign to the numerator minus square root of 3 minus plus multiplied by minus plus square root of 1. So here, this to simplify, 1 plus 1, 2, square root of 1 over square root of 2. The square root of 1 is equal to 1, so it's 2 multiplied by 1 over square root of 2. 2 over 2. Then we multiply both numerator and denominator by square root of 2, and here give us 2 multiplied 2 times square root of 2. A square root of 2 multiplied by a square root of 2 give us 2. We simplify, and then answer is square root of 2. This is the answer. Thank you. If you found it helpful, so please subscribe and like, and if you have any question you can ask me in the